Our speaker tonight is Dr. Taft Armandroff. Dr. Armandroff serves as the director of the University of Texas at Austin's McDonald Observatory and is a professor of the Department of Astronomy. McDonald Observatory is one of the world's leading centers for astronomical research, teaching, and public education and outreach. The observatory operates multiple telescopes, undertaking a wide range of frontier astronomical research under the darkest skies of any observatory in the continental United States. And if you've ever been out to the Texas Star Party, you can attest to how dark those skies are. The McDonald Observatory is just a few miles down the freeway, or the highway, not the freeway. The largest telescope that they have there is the Hobby-Eberly telescope with its 10-meter mirror. The McDonald Observatory also spearheads the University of Texas at Austin's partnership in the Giant Magellan Telescope, GMT, that's being built north of Chile. In northern Chile, excuse me. The GMT will be one of the world's largest and most advanced telescopes, and to tell us more about it is Dr. Taft Armandroff. So, Dr. Armandroff, I'd like to pass it over to you.
Thank you so much, Joe, and good evening, everyone. It's great to be with you. I'm just up the road in Austin, so it's great that we can do this by Zoom. Makes it really easy, and I'm going to try to share my screen.
And while you're doing that, Dr. Armandroff, I just wanted to remind everybody that if they did have questions, use the chat feature, and we will get to those at the end of the presentation in the order that they're received. So, thank you.
So Joe just mentioned the Hobby-Eberly telescope, and you can see on my title slide, there it is, our pride and joy in West Texas. And I'm going to mostly talk about the Giant Magellan Telescope tonight. I'm the vice chair of the board of the Giant Magellan Telescope. But I also, since we're all in Texas and McDonald Observatory is pretty accessible to y'all, some of you may go out to the Texas Star Party, stop by the observatory. I thought I'd give you a little update about the observatory, as a McDonald Observatory as well. And just wanted to go way back to how it all started. You know, not every university has an observatory, and not every state has an observatory. Like, I don't think Rhode Island has an observatory, do y'all? But it all goes back to William McDonald, and he was a banker in Paris, Texas, and he left his bequest to the University of Texas to build an observatory for the study and promotion of astronomical sciences. I think the people at the university were probably a little puzzled at that moment because they didn't have an astronomy department. They didn't intend to build an observatory, but Mr. McDonald really got them started, and he's led all the way to today and to our role in the Giant Magellan Telescope. So he has a great legacy, a world-class observatory, and a world-class astronomy department. The first telescope at McDonald was dedicated in May 5th, 1939, and we celebrated the 80th anniversary 3 years ago. We got to get going about planning the 85th. At that time, if you can believe it, it was the second largest in the world. And a symposium was held dedicating the telescope. Astronomy was a lot smaller of a field then, and you can see all the participants there. It included really famous astronomers at that time, like Chandrasekhar and Hubble and Baade. It was incredible. Everyone who was anyone was there. You can also see from the photo what a male-dominated field it was at that time, and we've changed a lot for the better. But the only woman astronomer at the event was Cecilia Payne-Gaposchkin. There's an image that was taken, you know, didn't have drones in those days or helicopters, so that was taken by a plane, you know, going right by the dome to get an aerial photograph. And that was the entire observatory at that time. The offices were in there, the dark rooms, and that was it. Now we've expanded a lot since then. And, you know, I think some of you are probably pretty familiar with this, but I thought I'd just go over what are some of the big questions in astronomy today, and what drives us to build telescopes, to build bigger telescopes, put telescopes in space, you know, get increased spatial resolution, get better ability to take spectra. And the way I look at it, we can boil most of our questions down into two categories. One of them is, are we alone? And the other is, what's the life story of the universe? And, fortunately, what your club does and what my observatory does, I think, should be of interest to everybody, because these are really big questions. These aren't some kind of tiny detail of putting an extra decimal place of accuracy in something. These are really say a lot about us as a species. So the "are we alone" question, what are we working on in there? How frequently do other planets have properties similar to Earth? And even 30 years ago, we didn't really know how common planets were around other stars, how common solar systems were. Now we know they're very common. So the questions have gotten a little more sophisticated. How frequently do planets have conditions that can support life? An atmosphere, liquid water, enough heating to not have everything be frozen or have the atmosphere sort of boiled off the surface. And from Earth, since the space between the stars is so spectacularly large, we have to do almost everything by remote sensing. So can we detect biomarkers in the atmospheres of other planets? And then in terms of the life story of the universe, we're studying the expansion rate of the universe and how it changes over the lifetime of the universe. And, I would guess about 100 years ago, we didn't even know the universe was expanding for sure. So we've learned a lot rather recently in human time. And now we know that the expansion is increasing. We have an accelerating expansion of the universe. We're doing a lot of work on that at McDonald Observatory. We do not understand that. How do we explain the formation of our galaxy? And then we know that after the Big Bang, we only had helium, hydrogen, mostly hydrogen, a little helium, and a tiny trace amount of beryllium and lithium. And how do we explain the nucleosynthesis of all the elements that are so common today, like carbon, oxygen, iron? And we've made a lot of progress on that, but we're not all the way there yet. So in order to do these things, we kind of need a mission statement at our observatory, and we try to give the best tools to the students and faculty and postdoctoral fellows at the University of Texas, but we also make McDonald Observatory available to other institutions of higher learning of the state, like Texas A&M, Rice, SMU, et cetera. We're a state-funded facility, so we, the onus is on us to do that. So, we want to make McDonald Observatory as capable as possible for studying all these big questions in astronomy. So, we won't need a number of telescopes. We need quite a bit of instrumentation. We need big light gathering power, good resolution, dark skies. But the Hobby-Eberly telescope is pretty much the largest telescope that we have the resources to build primarily by ourselves, any bigger than 10 meters. And we really need to join with other universities and research institutions to do that. So we have joined other universities to build the Giant Magellan Telescope. And in our program, we're also developing instrumentation, both for McDonald and the Giant Magellan. And when the Giant Magellan comes online, one thing we'll see is targets that were found at McDonald through like long, painstaking surveys, where the most interesting follow-up will come, with the Giant Magellan Telescope, because it can gather more light, and therefore the light can be analyzed in greater depth. For those of you who visited, and if you haven't visited, I encourage you to. We also, education and public outreach is a big part of what we do. We have a visitor center. We do teacher training programs in the summer to teach teachers how to instruct their classes in K-12 public schools about astronomy. And we have our Stardate radio program and magazine. And I hope some of you are able to tune into that on your radio stations or through our website. So that's our strategic direction. But I'm mostly going to talk about the Giant Magellan Telescope tonight, and it's going to be transformational for astronomy, and it's going to be particularly transformational for our faculty and students and researchers. This image on the top is a view of the telescope and the Atacama Desert in northern Chile, seen from the viewing gallery above the telescope. And there'll be, a number of advantages that GMT will present to allow us to make new discoveries, reach stronger conclusions in astronomy, be able to get a kind of data we've never gotten before. And the three pillars of those advantages are the site. The site is one of the absolute best in astronomy. Oops, I'm sorry. It's very dark. The atmosphere is very stable. It's a high elevation. And then the resolution that we'll get with the telescope is going to be dramatically better than anything we have at McDonald Observatory, so the spatial resolution. And then we'll have a large light gathering power. So let me go into why that is. This is an image, just a schematic rendering of the telescope. So you see the largest mirrors that are built today are about 8.4 meters in diameter. That's about 27.5 feet. And we're going to put together 7 of those with one central mirror and then 6 around the edges to form these will all be sections of a parabolic surface. And we'll have our secondaries up here. So it'll be a really spectacular system in terms of the light gathering power and the resolution. This is the enclosure here, and you can see the vents to allow it to equilibrate with the night air. And so just to go back to those high level benefits, we'll have about 5 times the collecting area of the largest telescopes today. So about 5 times the collecting area of the Hobby-Eberly telescope or the Keck's on Mauna Kea. In terms of spatial resolution, I'm sure you all see the spectacular pictures with the Hubble Space Telescope. With adaptive optics, GMT will have 10 times the spatial resolution of Hubble and about 4 times the spatial resolution of James Webb. I've already talked about the site conditions. The Southern Hemisphere access is going to be fantastic for us because our astronomers can't get very far south from McDonald Observatory, of course. So it'll open up a whole new area of the sky to us, but also around the equatorial area where you can get both from McDonald and from GMT. We'll have a lot of follow-up work there. And then strategically for UT, few universities will have, guaranteed access to GMT. I'll show you who will in a moment, but that'll be a real strategic asset for recruiting students and recruiting faculty members. And already we've had a number of faculty members come to UT where we were competing with Ivy League schools and other prestigious institutions where the GMT was a key selling point in coming to Texas. So it's been really great for our faculty development. I'm going to just show you a little video here of what the telescope's going to look like in more depth. So you can see it's at a very arid site that we've leveled the site, and I'll show you more. You can see the 7 mirrors, the dome rotating, the biparting shutters, and then a lot of ventilation here to make sure we get in good equilibrium with the night sky. This is an office building over here, kept out of the dome so we don't generate heat. And these are the utility buildings where we'll have things like that generate heat and vibration, things like pumps, compressors, things like that. So the mirrors are the hardest thing with these big telescopes. They're hard in all ways. the accuracy you need to polish the mirror to is spectacular. So you need to polish it to about a 20th of the wavelength you want to work at, and we're going to work into the blue. So that's really demanding. The mirrors are really heavy, so we lightweight them by making them not solid, and then you have to make these huge mirrors, and you have to transport them to, they're made in Tucson at the University of Arizona, underneath the football stadium in the Richard Karras Mirror Lab, and you got to get them all the way to Chile without breaking them. And you can't order them from a commercial company. You can't pull up your Edmunds Scientific Catalog or call Mead. You really got to do it yourself. So we started very early on the mirrors, and we have 2 of them that are complete and formally accepted. We have a 3rd one where we just finished the polishing and we're going through the formal acceptance procedure. I'm sure it'll be accepted. We have another one that's been cast and the rear surface has been polished. You got to get the rear surface flat. And then we have 2 others that have been cast, and we've done some preliminary work on them, but we're not that far along. And finally, for number 7, we have the glass in hand, and it'll be cast next year. So we're really pleased at where we are with the mirror production. We've done a lot of work on the site as well. This is the site in Chile, and you can see it's very, very dry. We're building on a piece of land that the Carnegie Institution for Science has owned since like the 1960s. And they're subleasing us for 100 years, this particular mountaintop. So it's already protected in terms of light pollution and from mining. So we've built the roads, we've leveled the summit, and we've built a support site for workers and visitors, and like a kitchen and a recreation area. And then this is where the telescope will go. We've dug the footings, and we're pretty much ready to pour concrete to the footings. We're not doing it immediately because it's very costly to do that. We've put in a water system that pulls up water from the valley below and treats it, so that's in place. We have an office building, and these are towers that monitor the things like the site, the stratification of the atmosphere and the temperature gradient. And we also have, you can barely see it, but there's a little seeing monitor telescope there. So we've made a lot of progress. It's very remote. It's a 2-hour plus drive from the nearest city, La Serena. And here's some of the construction that went on the site in 2018. Just it's fun to see a little progress. I mentioned that there'll be relatively few institutions who have access to this, and we have 13 partners right now. So, and I think we're the only state that has 2 partners in it. So the University of Texas at Austin and Texas A&M are both partners. And I imagine in your club, various of you have studied at UT or A&M, or perhaps your other family members have studied there. But you can see we have a lot of the big universities in US astronomy. We have the University of Arizona, we have Harvard, the University of Chicago, Smithsonian, Carnegie. Then we have some international partners. We have the Australians, and the Koreans. We have one institute in Brazil, and we have the Weizmann Institute for Science. I see there's a question in the chat. Thank you. What's the source of the electricity? Right now, we just get it off of the Chilean grid. What we plan to do when we're in operation and using more electricity is to contract with a solar farm. There's a lot of solar farms in Chile. And so a lot of our supporters would like to see us be a green observatory. We're also trying to bring in the National Science Foundation in the US as a supporter, and they've asked us to prepare an analysis of how green will be. So it's interesting, when I first got into astronomy, no one was asking those questions because we weren't something like a steel mill or a chemical plant. But now there's a lot more awareness, and we can contribute as well. I hope I've answered your question, Jerry. So what are we going to use this for when we have it? It's going to just be amazing. But, and we don't even know everything we'll use it for, because we're going to discover new problems in astronomy, and a lot of observatories, like what we're doing with the Hobby-Eberly telescope, and looking at dark energy and dark matter. Those weren't really part of the plan. So, but this is the plan right now, but I have to emphasize to you, it's a very versatile facility. It works in the optical and the infrared. It has imagers and spectrographs. It has adaptive optics. It's got it all. So it can do anything that our faculty can throw at it. But the primary areas that we're selling it on and that we're committed to advancing is direct imaging of exoplanets. So taking images of planets around other stars, that's very hard to do. The scale of the universe the scale of our galaxy is so large that, planets are really, it's trying to look like for a firefly next to a searchlight. But with adaptive optics, we're going to image a bunch of direct image of exoplanets. And one of the most intriguing ones is 51 Pegasus B. No, I'm sorry. Proxima Cen B goes right overhead at the GMT site. It's one of the nearest stars, Proxima Cen, and Proxima Cen B is detected by radio velocity to be an Earth-like, we think, an Earth-like planet. And we believe we can take a direct image of it with GMT. The other thing we want to work on, and I'll say a little bit more about this, is exoplanet atmospheres. So that's a big question today. We now know that planets are fairly common, but we don't really know how common the atmospheres are. So that's a huge opportunity for us. First light in the universe, James Webb Space Telescope is working on this right now, and we've done a lot of work with the Hobby-Eberly telescope on this, but we want to go back and look at the earliest galaxies and see how long it took after the Big Bang for the first stars to form and what the conditions were like. I talked about nucleosynthesis earlier, but how did we get all these chemical elements? A lot of the earlier galaxies in the universe have a lot more heavy elements than theorists were expecting. So how did that get cooked up so quickly via supernovae and potentially other means? We still don't have an answer for what dark matter is. So one really important observation is, what's the smallest scale that dark matter clusters on? So we're going to work on some of these ghostly dwarf galaxies around our Milky Way to really study in extenso their dark matter content, and that'll constrain a number of theories of dark matter. And then dark energy is incredibly important. It's 2/3 of the mass energy budget of the universe, and we have no idea what it is. I think we know a lot more about dark matter than we do about dark energy. So this is going to be a great tool, a great resource for the astronomers in the consortium, but in particular astronomers in Texas, to study these topics. And I hope you all, as the club, as we have GMT come online, that you'll invite some speakers who are doing research on these topics, and maybe tell you what they learned from the Giant Magellan Telescope. So let me just say a little bit more about exoplanet atmospheres, because this is an area that we really haven't made that much progress on yet. And I think GMT is going to tell us a lot. So this is what the Earth's atmosphere has been composed of as a function of time. And, very early on, it was pretty nasty: ammonia, methane. And this has gotten from things like the fossil record, I think, in the ice at the South Pole. But you can see, as plants started to come on, we got oxygen. And then, of course, we need oxygen. So wouldn't it be amazing to look at other planets and Earth-like planets and see where they are in this kind of evolution of what their atmospheres are doing? And we got the oxygen mostly from these from algae and things like that. But also, eventually there were animals, and they produce other things in the atmosphere, like methane. So if you can isolate the light from the planet and you can put it through a spectrograph, and you can look for the fingerprints in the spectrum of oxygen and methane, you can learn a lot about an atmosphere. It's a tough observation. And the primary tool, we have a secondary tool and a tertiary tool, but the primary tool is transit spectroscopy. So for stars where the exoplanet goes right in front of their star, right there you have the light from the star shining through the planet's atmosphere. And then when it goes behind the planet, you have the complete, behind the star, sorry, you have just the star without the light shining through the planet's atmosphere. So if you get a really, really precise spectrum at those two times and you subtract them, you'll just be left with the spectrum of the star's light going through the planet's atmosphere. And that'll tell you, what kind of, what the composition of the atmosphere is. I mean, that's how we tell the composition of stars, of course. We take spectra and we look for lines of oxygen, et cetera. So what we're really after are things like oxygen and ozone and methane and carbon dioxide. Those are all signs of, some kind of biological process going on. Some of these others, like carbon monoxide, is a false positive. So we're really the true positives are oxygen and methane. So we're really excited to try to look for those. I'll tell you I talked about transit spectroscopy, but the other way to do this is using adaptive optics to just get really, really high resolution images. Then you can just separate the star and the planet and just take a spectrum of the planet. And then the third way is, because the planet is going around the star, the Doppler shift will shift these lines slightly in the planet's spectrum compared to the stars. So you can use that. It's very tricky, but you can, we believe simulations say you can do it. So what are we doing for GMT in Texas? We're part of this. We have about a 12% share right now of the stock in GMT Corporation, but what are we doing? Well, there was a worldwide competition to build the instrumentation for the telescope. And there's only 5 instruments that are being developed, sort of for the early phase of GMT. The instruments, it's a lot easier to add instruments later. It's very difficult to change the telescope. So we're building one of the 5 instruments. We're competitively selected. We're building a high resolution near infrared spectrograph. And it uses a grading technology to disperse the light that uses some of the same techniques used to make semiconductors. So we use this silicon immersion grading. And one of the ways we won the instrument is we built a prototype of it and we deployed it at McDonald, a much simpler, smaller version. It's called iGrins, and we did a Pathfinder science there. So we're already doing, we're taking baby steps towards doing this science on GMT. We're also contributing the lessons that we've learned from McDonald towards, how to operate GMT. And as I said earlier, we'll feed interesting celestial targets that we find at McDonald and think they need some follow-up to GMT. Eventually, we'll have a remote observing facility in Austin so that all of our students and faculty don't have to travel down to GMT. Some of it'll be Q observing. I don't know how many of you are familiar with that. That's where a professional observer is at the telescope and you specify the observations very carefully, and then you get the data the next morning in a computer file. Some of it'll be remote observing where you have to make judgments on the spot. And some of it, people will travel to Chile, but we don't want to spend all our money on plane tickets to Chile. So we want to use those other modes. And then eventually there's going to be an operational headquarters for the GMT project. And we want to attract it to the UT Austin campus. I'm sure there'll be somewhat of a competition for this, but we think we have a good case. We're kind of central in the US, so we're easy to get to. There's flights from Houston to Chile and from Dallas to Chile, so we offer more direct connections than most places. And we think we have, a nice place to live, low tax rates, all that. After all, Tesla came to Austin, why not GMT? And then I just wanted to show you the scale of the GMT, because you say like 8.4 meter mirrors, 25 meters across. That doesn't, I mean, you can think all that and, it's all accurate, but you need a point of comparison. So I don't know how many of you have been on the UT campus, but this is what GMT is going to look like compared to the tower at the center of the UT campus. And you can see it's not quite as tall, but a lot wider. And you have to make it a lot more precisely, I think. So that just gives a sense of GMT, of what a big project it is. If we still have time, I'd just like to say a little bit more about visiting McDonald Observatory and what we do out there for the the non-research community, something that might interest you all. I'm sure some of you know all this, and I don't want to bore you, but we have a visitor center that you're all invited to. We give star parties, depending on the season, 3 or 4 nights a week. We give telescope tours. When it's not the pandemic, we get 95,000 visitors a year. I already mentioned Stardate Radio and Magazine. We're on 300 radio stations nationwide, and we get 3.5 million listeners per week. And then I mentioned that we have, maybe 80 teachers a year come to the observatory in the summer and learn how to incorporate astronomy into their science curriculum. But what motivates us to do all this is not just, showing off the observatory, but we think astronomy is a great gateway to the STEM fields. And I'm sure you all at the Houston Astronomical Society see that same thing with your work when you bring young people out to your dark site or, engage them. Kids are just fascinated by the stars. So we hope to continue to do this and train the next generation of scientists and engineers. These are, school groups to the observatory. We haven't had as many school groups coming in person, but we do some of it by video conference. That's a video conference there. And then here's our star parties at the observatory, the Frank Bash Visitor Center, and the telescope park there. And then just give you a little update of that. We had to shut down during the pandemic, of course, because as a precaution to not have a super spreader event. But since then, we've essentially returned to our pre-pandemic features. So we're still giving the twilight guided constellation tours. We're doing daytime guided tours of the observatory, introducing the telescopes, what the telescopes do, and research. We're video conferencing to K-12 classrooms, and we're still open for classroom visits. We just installed a new exhibit on protecting dark skies at our visitor center, and I think Joe mentioned your live streaming programs. We're doing live streaming once a month. We were doing that more commonly during the pandemic because we had all these professional astronomy educators and no one was coming to the observatory, and it was sort of like it was like a trained athlete who couldn't run. We had to do something. So those turned out to be very popular. And if any of you don't know about them, I can provide a link. So here's our dark skies exhibit, our brand new dark skies exhibit. And if you haven't seen it, I recommend it. We're trying to raise awareness of dark skies. It was developed by our visitor center team, and in consultation with some professional museum display exhibits, and it was funded by the Apache Corporation, which is headquartered in Houston, of course. We're super grateful for their support, but we try to make the exhibit, accessible to people who aren't amateur astronomers, who aren't professional astronomers, who aren't scientists, but just people, who might have lighting in their yard or might work for a municipality or county and have some influence on lighting, or might have a small business that has lighting, and we really want to raise awareness. So we talk about our Dark Skies initiative in West Texas to keep things dark, keep the light shining down, not up or sideways, and we talk about win-win solutions. And part of the motivation for this is, some of you may be aware of this, but we've worked with the International Dark Sky Associations and the municipal and county governments, and the national parks and the Nature Conservancy, et cetera, to create a Greater Big Bend International Dark Sky Reserve. There's a map of it. The core areas are in dark green, and the peripheral is in lighter green. And then there were already some pre-existing IDA approved sites within there, like Big Bend National Park and Big Bend Ranch State Park, the Black Gap Wildlife Management Area, et cetera. So we built on an existing, strong foundation and a community that already appreciates dark skies, which is wonderful. So it's 15,000 square miles, the largest dark sky reserve anywhere. It's got Jeff Davis County, where the observatory is, but also Brewster, Presidio, and sections of Reeves County. It's the first dark sky reserve that crosses an international border. And we had to work with all the governments to strengthen lighting regulations, and they were very cooperative. That was wonderful to see. And it's a credit to all of those government entities. So it helps preserve our research mission at McDonald Observatory, but of course, it helps with the outreach mission. I'd like to think it also helps for the quality of life out there, for just people who have their own small telescope or want to look with binoculars, or just don't want to live in a super bright area. And I'd like to recognize the Nature Conservancy and the Big Bend Conservation Alliance for helping us. So that's my my deck of slides that I thought might interest this group. A little GMT, a little McDonald Observatory, a little public outreach, and a little dark skies. And I'm not sure where I am on time, but I just want to thank you for the opportunity to connect with all of you, and for giving up part of your Friday evening to talk GMT and McDonald.
Thank you very much, Dr. Armandroff. That was an absolutely fascinating presentation. And I will echo what you said. If you have not had the opportunity to go to the McDonald Observatory, participate in a star party over there and whatnot, it is certainly not to be missed. So the next time you're heading down to Big Bend or to Fort Davis or anything else like that, even if you're going to the Texas Star Party, it is certainly worth the time to go and explore everything that the McDonald Observatory has to offer. And as well, Bill Pellerin is on with us tonight. And I believe, Bill, I don't want to butcher this, but I believe you're director for the Board of Visitors at the McDonald Observatory. And he often sends us, forwards those emails that you send out, Dr. Armandroff, about those public star parties. So we do join those quite often. So thank you for continuing that work. All right.
Thank you.
Oh, I'm sorry, go ahead.
I know we have a number of members of our Board of Visitors on, Bill Pellerin, Lori Valensic. I see Debbie Moran, I think Chris Morissette. I hope I haven't missed anyone, but thank you. Thank you for your engagement with the observatory and for helping to spread the word, and for your leadership.
Absolutely, thank you. Okay, well, does anybody have a question they would like to ask of Dr. Armandroff? If so, please come off of mute and feel free to ask directly.
Joe, I've got a not so much a question, but just a comment, and I wanted to tell Dr. Armandroff one of the best observing opportunities I've ever had was on the 82-inch telescope there at the observatory. It would have been 2018 when the Texas Star Party was going on. Mm-hmm. And it was awesome. I just have to say, I hope now that the COVID pandemic is more or less behind us, that there'll be more opportunities for public to look through some of your bigger telescopes at the observatory.
Absolutely, we've started that back up again. And the most observatories, you can't get that close to the telescope for one reason or another. Before I came to Texas in 2014, I was the director of the Keck Observatory around Mauna Kea, and there's a lot of sensitivity about people going up Mauna Kea. So it's really nice to see people looking through our 82-inch telescope, looking through our 36-inch telescope. And we had a lot of restrictions during COVID. There were state restrictions and university restrictions, but we call these special viewing nights, and you can go onto the public website and you can see how to sign up for those. So there's sort of like a more advanced version of our star parties.
Absolutely. And if Renee Daly is on, she's our field trip and observing chairperson. We might have to schedule a club trip up there. So everything I've heard from those who participated in that has been absolutely fantastic.
So glad to hear that.
All right, who else has questions for Dr. Armandroff?
Joe, this is Chris Morissette.
Hey, Chris.
Yeah, hey, Taft, thanks so much for the presentation tonight. Could you talk a little bit about the Texas Advanced Computing Center and how that plays in both the GMT and the McDonald Observatory research activity?
Well, thanks, Chris. That's a great point. And just over my career in astronomy, which the importance of big data has grown so much. And when I started out, pretty much everyone would write their own software to analyze their digital data. That's not very productive. It's a lot of duplication of effort. So what we do at McDonald Observatory now is kind of extraordinary. The University of Texas has a fiber optic ring around the UT system. So there's a fiber optics that goes up to UT Permian Basin in Midland. And then we have a private fiber optic that goes from the observatory up to Midland. So we get on that fiber optic network. So as people take data during the night with the Hobby-Eberly telescope, it gets saved to a local disk there, and then it gets transported over this network to the Texas Advanced Computing Center, which is one of the biggest supercomputers in the world. It's up there near the Domain in Austin, if any of you have ever been to the Domain. So I don't know, shoe shopping and supercomputer shopping located strategically next to one another. So that we have software that runs and basically does all the grunge work of we have 36,000 fibers the Hobby-Eberly telescope. So it figures out which of those fibers landed on stars and flat field calibrates it, takes out all the instrumental effects, the sensitivity effects. And basically the astronomers get a little email in the morning that says, we've reduced your data. So instead of people like laboring for months to sort of pull this, what the stars and galaxies spectra are out of this, all the hard work has been done and they just need to use their insight to analyze the data. Now, with the Giant Magellan Telescope, the National Science Foundation has built fiber optic networks down to Chile. So we'll have really fast fiber optics, connectivity on the summit in Chile. And we're working with the National Science Foundation and others for when they come in to have an archive of the data and automatic processing. And we're hoping it'll be hosted at the Texas Advanced Computing Center. That hasn't all been established yet, but the National Science Foundation is one of the supporters of the Texas Advanced Computing Center, so it'd probably be appealing to them. Did I answer your question, Chris?
Yeah, I think the computing center, you got a lot of data that's coming in, so that center is pretty key to getting through everything and making it all make sense.
You're so right. We couldn't do it without them.
It's amazing how important data is. I think, Don, if I'm not mistaken, we had Dr. Arnie Hendon here several months back to talk about the Vera Rubin Observatory, and it was amazing to see how much data was actually being generated by the observatory there, and kind of disheartening to hear about what the lifetime of that data would be. How much of it would be discarded after a period of time. But being in technology myself, I certainly can appreciate the problem that a massive amount of data like this presents. But hopefully we'll be able to get as much out of it as we can.
Yeah, we'll produce GMT will produce a lower rate of data than the Vera Rubin telescope. So we will like lower rate, but maybe higher quality. So we won't have quite the problem that they have, but yeah, they're impressive.
Well, if I understand correctly, Dr. Armandroff, one of the key findings of the last decadal survey of astronomy was that there needed to be work on data compatibility and storage and so forth. Is that something that if the advanced data center served the GMT, is that something that you'd be working on as well there?
Absolutely. We need to make the data formats more compatible and easily accessible. And the decadal survey also endorsed the Giant Magellan Telescope, since you mentioned it.
It did.
It's top priority.
I should have said that. We actually had a focus on the major observatories that were highlighted in the decadal survey this year, and that's your offer to talk about the GMT fit exactly what I was trying to accomplish with our program this year. So thank you very much.
You guys work at a very high level. I mean, I think there's a lot of amateur astronomers who, you tell me if I'm wrong, wouldn't know what the decadal survey is. So I'm very impressed that you're following that.
We have a wonderful group of folks and some pretty well accomplished amateur astronomers, people with supernovae discoveries, contributions to proper scientific journals and other things like that. So we're very proud of the work that our members do here. Absolutely. Okay, well, I was going to say, do you have time for one more question, perhaps, Dr. Armandroff?
Oh, of course.
Okay, last question. Who wants to get in and ask away? Okay, nobody's coming up. I'll ask. I don't know if I missed it, but when are we anticipating first light with the GMT?
Around 2029.
2029.
So it's the patient. It takes a lot of patience, unfortunately, but it's mostly getting that structure all made and then shipped to Chile and then reassembled and put together, and then getting the enclosure made, shipped to Chile, reassembled is some of the drivers. There's other drivers as well.
Understood. Well, Dr. Armandroff, thank you again for spending some time with us this evening. I can certainly speak for everybody else here and saying that we've learned a lot. We're really excited about all of the great work that is happening at the McDonald Observatory with the University of Texas Astronomy Department. And we're really proud that this is something that is available here in the great state of Texas. So thank you and good luck with all of the future work that you all are doing.
Thank you so much. It's great to visit with you all, and hope to see you out at McDonald's sometime.
Absolutely. I can't wait to get there again.
So, Joe, this is Bill.
Hey,
Can
Bill.
I make a quick comment, please?
Absolutely. Anything.
Yeah. We talked about the Board of Visitors for the McDonald Observatory, of which I am a member, and anybody who is a member can nominate new members for the Board of Visitors. And if you're listening to this and you think you might be interested in joining us at the Board of Visitors, you can contact me or any of the other HAS members who happen to be Board of Visitors members, and we can talk to you about what it's all about and what it takes to get that moving.
Absolutely. And Bill, thank you for bringing that up. I was going to start the process a few months ago, and then I caught COVID. We had to put everything on hold. So we're
not going to let you off the hook, Joe.
No, not at all. I'm not going to let myself off the hook either. So, all right. Well, thank you, everyone. If you have questions about that, if you want to get more information from Bill, please send me an email, president@astronomyhouston.org, and I'll make sure to get you all linked up with Bill or any of the other members who are BOV members as well. So with that, I'd like to thank everybody for joining us. Our next monthly meeting will be, our novice meeting will be Thursday, October 6th at 7 p.m. online. And then the following day, we'll have our general meeting, October 7th at 7 p.m. online as well. So if you have any questions, like I said, please reach out to us. We've got a lot of great things happening here in the club this month. Take a look at our events calendar. Please join us for one of our events coming up soon. And we hope you have a great evening. Stay safe, and we'll talk to you soon. Take care, everyone.